All right, folks. Well, welcome back. Sorry about yesterday. I wasn't able to post the lecture notes for you, but I was happy to see most of you yesterday. For the few of you who I did not see, please make sure you check in with me. Either through email. Let me know through again email. Just email me and let me know how things are going on, how you're doing with the lectures. And then come and see me so I can kind of give you an idea of what we talked about yesterday in regard to what we'll do moving forward. Okay, so it's good to see that everyone's doing well. Again, let me know how things are going. You don't have to wait until we meet. You can come by and see me after school and get that extra help that you may need, or just tell me how things are going. Okay, available 1:30 to 2:30. Make sure you take advantage of that. Okay, folks. All right, so let's continue on with our discussion of kinematics, and let's talk about acceleration. We left off yet on Wednesday with Tuesday with the discussion of acceleration and how that relates to velocity. We know then, remember, we talked about this, that we can determine acceleration. I gave you the equation for it. We'll talk about the graph hopefully today in just a moment. But we know that the acceleration represents then a change in the velocity over a given time interval. Okay, that change in velocity takes into account the instantaneous velocity at some time final and the instantaneous velocity at some time initial. Okay? And so that is going to be then how we determine acceleration. Essentially, acceleration is a change in the speed. And since velocity is a vector quantity, it has direction. Acceleration also represents a change in direction as well. And I pointed out to you at the very beginning of this particular unit, we're going to leave out that discussion of changes in direction and how that relates to acceleration. We'll leave that out of the discussion until towards the end of this kinematics unit when we talk about two-dimensional motion. And so for right now, what we're going to do is we're going to talk about a change in speed, a change in speed representing then an acceleration. Okay? And so we saw on Tuesday then that if you have an object that does not change its speed, okay, an object whose speed is constant. So if v is constant, okay, which means then it does not change. So we saw then if v is constant, acceleration then will be 0. Okay, units being then meters per second squared, length over time squared. Okay, so when the speed is constant, when the velocity is constant, going in the same direction, it doesn't change its speed, the acceleration is going to be 0. Okay, so that's going to be what we refer to as constant 0 acceleration. Okay, so we're going to talk in this chapter then, in this unit, about uniform acceleration. Uniform acceleration, which is what I refer to here. Uniform acceleration then represents what we refer to as acceleration that is going to be constant. Okay? So in this, when we talk about kinematics, and since we're leaving out the discussion of forces and what causes an object to change the way it moves, okay, so we're going to talk about then uniform acceleration, which means then in our discussion here, the acceleration doesn't change. Okay? Again, acceleration doesn't change. It doesn't mean that the speed doesn't change. Acceleration stays constant. Okay? All right, so with that said then, we were able to analyze through a pictorial diagram and also through a particle diagram the situation in which you have constant 0 acceleration. Okay, so acceleration is 0 and velocity is constant. Now, constant velocity could mean that the velocity is going to be 0, which means that the object is not moving. If an object is not moving, it has constant velocity because it's not changing its velocity. But that doesn't mean that the constant velocity means that the object is not moving. We can have an object that is moving. That means it has a velocity that is not equal to 0. It could be moving, but it doesn't change its speed. It doesn't speed up. It doesn't slow down. And if that's the case, then that's what we refer to as constant velocity. Okay. All right. Very good. So let's go ahead then and let's take a look at a situation in which the velocity does change. Okay. So let's take a look at what we have here. Okay. So if you look at the vector quantity, so again, same type of diagram. I gave you the pictorial diagram here, and then you have the particle diagram on the bottom. Okay. And if you notice here, what happens is that, and it's a little bit easier to see, I think, with the particle diagram here, that if you look at this here, you notice then that the object, the car here, changes its displacement. Okay, so if you take a look at this displacement, each of these displacement intervals then get longer and longer. That means then, and remember, the key here then is that the time interval is here. The time interval to get from point A is the initial position to the second position here is the same. The time intervals here between each instance is going to be the same, which means then the velocity here, the velocity in this interval, and the velocity in this interval are all different. And if you notice here, the velocity will increase because if the object, if the car is covering more distance, if it's covering a greater distance in the same time interval, the velocity is going to be greater. So you can imagine that the velocities then will be greater as we move towards the right. So the velocity here is changing. So we have then, in this case then, a changing velocity. So the velocity is changing. And so if the velocity is changing, and so you can imagine then that the velocity from V2 to V1, if the velocity is changing then, that means that we have a delta V. And so looking then at the equation that I gave you earlier, okay, if we have a delta V that is not equal to 0, then we have an acceleration. And there is our vector for the acceleration. Okay? And if you notice then, the acceleration here is in the same direction as the velocity. The arrows are pointing in the same direction. And so I think if you can see that, then you can imagine then that the object here, the car then is speeding up. If it's starting to go faster and faster, if the velocity towards the right-hand side is greater than the velocity on the left-hand side here, the car here is speeding up. And so that's going to be key, folks. So whenever the velocity and the acceleration are in the same direction, the object is speeding up. How do we know that it could be in the same direction? If we're not given these vector arrows, if we're not given a particle diagram or the picture here, okay, we know that these will be in the same direction if they have the same sign. Okay, same sign. That's why then, if you take a look at this, and again, we're arbitrarily deciding then that along the positive x-axis, it's positive. The velocity here, all the velocities are positive. And if you notice here, all the accelerations are also pointing towards the right. So all the accelerations are also positive. Velocity and acceleration, when they're in the same direction, and let's go ahead and highlight this for you, whenever they are in the same direction, okay, the object is speeding up. Okay, so positive velocity, let's go and take a look at here. Positive velocity, positive acceleration. Okay, in this case then, the object is going to be speeding up, but do mind you, do keep this in mind, that just because both of these are positive, doesn't always necessarily mean that they are speeding up. Remember, the key here to understanding this is that we have then the same sign. Okay? So which means, and you can imagine if we flip this around, that means then the acceleration of the velocity is in that direction. If the velocity is negative velocity, and if the acceleration is also negative, so you can imagine this, if the acceleration is also in that direction. Okay? So in this case then, are the two vectors pointing in the same direction? Yes. Which means then that if the velocity is negative and the acceleration is negative, you still are speeding up. So the key here then is not so much that the velocity and the acceleration are positive. The key here then is that the velocity and acceleration have the same sign. They have the exact same sign. If that's the case, then that's when the object is speeding up. That's what you want to look for. Okay? That these arrows are pointing in the same direction, object is speeding up. Okay. All right. Hopefully, very good. Hopefully you were able to get that. What I'll do is I'll post these notes for you. I think it's been helpful for my other classes. I've had that request before. I will also post these notes for you as well. Okay. All right, let's go ahead and let's take a look at what happens. Okay, so let's take a look at what happens when the acceleration is negative. Okay? If you have a negative acceleration, first of all, make sure you understand that negative acceleration just means then that the acceleration now is pointing in the negative direction. It's pointing in the direction that we refer to as negative. And again, this is arbitrary, but if we're going to talk about motion along the x-axis, towards the left of the x-axis is going to be negative, towards the right is going to be positive. So whenever you have a negative acceleration, okay, this doesn't necessarily mean that the object is slowing down. Remember, speeding up, slowing down depends on the sign of the acceleration when compared to the sign of velocity. Okay? And so what you need to make sure you keep in mind here, that if the acceleration and velocity are both negative, and I'm going to highlight this again for you folks, I want to make sure you understand this. If the acceleration and the velocity are both negative, which means that again, they have the same sign, the object is speeding up. You have an object speeding up because they have the same sign. So make sure you keep that in mind, which means then The acceleration is in the negative direction. If the velocity is also pointing in that direction, which means that the velocity is also negative, if these two are in this have the same sign, the object then is speeding up. Okay, even though you have a negative acceleration, if the velocity is also in that negative direction, you still are dealing with an object that is speeding up. Okay, so the sign, make sure you look at them. You are comparing the signs of both the velocity and acceleration. Now, just keep in mind that we talked about velocity and displacement. The signs of the velocity and displacement must always be in the same direction. If you're moving if you're speeding, if you're moving in a certain direction, your displacement will also be in that direction. However, the acceleration and the velocity do not necessarily have to be in the same direction. Okay, so make sure you keep that in mind as we go through this. Okay. All right. Let's go ahead then and let's continue and let's do a quick analysis of this. Okay, so let's go ahead and take a look at this. Okay, all right, so let's go ahead and take a look at a situation then where the acceleration and the velocity are in the opposite direction. So let's go ahead and take a look at, let's analyze this time interval again. So this is the start here, so we'll call this t is equal to 0, and this will be t 0 seconds. Okay, so this is t initial. T final is over here at some time. Okay, so the object is moving towards the right. So the object, if you notice that the velocity is towards the right, because the velocity is positive in this case, then velocity is positive. Let's look at the particle diagram and let's analyze the particle diagram really quickly. Each time interval then is going to be the same. Okay, so this is going to be T1, time interval 2, time interval 3, time interval 4. All time intervals are equal. Okay, so the time intervals are equal. If you take a look at the displacement, okay, delta x1, delta x2, delta x3, and delta x4. If you notice then, the distance that's being covered over the same time interval gets smaller and smaller, which means then the velocity is getting smaller and smaller, which means then velocity of 1, velocity of 2, velocity of 3, and velocity at time 4. Okay, therefore then, if you take a look at this, the velocity of 1 is going to be greater, velocity of 2. That means then it's greater than the velocity at time interval 3, it's greater than the velocity at time interval 4, which means that if you take a look at this, then the object is slowing down. Okay, if we have the velocity is getting smaller and smaller, the object is slowing down, the car is slowing down. Now, in each case, the velocity is still positive. You notice the arrows here get shorter and shorter, which means it's slowing down, unlike what we saw in the previous slide, where the arrows get longer and longer, but they all are still pointing towards the right in the positive direction. However, if you take a look at the accelerations, the arrows here are all pointing in the opposite direction, which means then they are negative. And if you notice here, the vector for the velocity, the vector for the acceleration are in the opposite directions. And so let's go ahead and highlight that. If the vectors are in opposite directions, and make sure you keep this in mind, that means then that the object will be slowing down. Okay, so if the vectors are in the opposite directions, they have to be slowing down. Make sure you keep that in mind. So let's make sure you write this. So here we have the velocity being positive, the acceleration being negative, which means then they have opposite signs. The object is slowing down. And that's what you want to look for when you look for, when you make that determination of whether an object is speeding up or slowing down, okay? Okay, so with that said then, when the velocity is positive and acceleration is negative, the object is slowing down. We pointed out up above, so make sure you keep this in mind right here. Okay, opposite signs, slowing down. Okay. Now, with that said, I would ask you to consider this here. Okay, let's consider another situation. I want you to write this down on your paper. What if the velocity were negative and the acceleration were positive? Okay. What's the object doing there? Is the object speeding up or slowing down? So real quick on your piece of paper, I want you to write down then what's happening in this case here. So with the velocity then in the negative direction, acceleration in the positive direction, what's the object doing? Speeding up or slowing down? Okay. Okay, hopefully everyone saw then that here, opposite signs, which means then the object will be slowing down. Okay, so again, all you will be looking for then is whether the signs are in the same direction or they are in opposite directions. So make sure you keep that in mind, okay? All right, very good. Let's go ahead then, and let me ask you to take a look at number 6 here. Okay, answer these 3 questions here really quickly. Okay, and then I want to go over this with you. Okay, so take a look at these 3 questions here. Take about 3 minutes or so to write down your answers. Then I want to go through each one of these with you, and then we'll continue on. Okay, so go ahead on your paper, write down the answers for these 3 here, true or false. And I'd like you to just give a really quick rationale, 1 or 2 sentences, explain your answer. So tell me whether each statement is true or false, okay? And then write down a sentence or two explaining your answer. Okay? Go ahead, take about 3 minutes to get that done. All right, let's go ahead and let's take a look at what we have here. Okay, so let's go ahead and let's work this one out together. Okay, so for the very first one, we're told then we have a car, and so let's go ahead then and let's define the direction here. I'm going to go ahead and do this for you. Let's go ahead and define the direction, and I'm going to go ahead and define the direction along the x-axis. We have a car here moving along the east-west direction. Okay, so the direction here, east towards the right, okay, west towards the left, okay, and if we're going to follow convention then, negative towards the, positive towards the east direction, negative towards the west direction, okay. So we're going to start out and we're going to make that our direction, okay, so we need to have direction here, okay. All right, let's go ahead then and let's consider the very first case then, okay. We have a car then, and let me go flip back and let's refer to this really quickly, okay. Okay. We have a car then traveling the eastward direction. Okay, true or false? Its acceleration must also be eastward. Let's go ahead and draw that out. Okay, let's draw that out really quickly, and then we'll work through this. So in the first case, then we have a car. So let's go ahead and draw our little car here. Okay. Okay. We're told then that it is traveling eastward. Okay. So it's traveling towards the east. Okay, and I'm sorry. Let me just make sure that I got the directions right here. Okay. Oh, sorry, I did that wrong. Okay, so let's go ahead and they tell us already. And let me go ahead and erase this here. Sorry, folks. Okay, they actually tell us what the directions are. Okay, so let's go ahead then and let's designate positive as being west and negative as being east. Okay, so we have a car traveling in the eastward direction. Okay, it's going to be negative. And again, if you notice here, this is an arbitrary assignment. So we have a car moving in eastward direction, okay? And then it asks us, and I'm sorry, I have to move back because I don't have the notes with me today. If the car, its acceleration must also be eastward. Okay, so here it is. So we have a velocity. The velocity here is going to be negative, okay? Because it's moving in the eastward direction. If it's moving in the eastward direction, its velocity is negative. All right. So true or false, if this is the case, the acceleration must also be negative. Okay? The answer here is going to be false. Okay? Just because an object is moving in the negative direction, it doesn't mean that the acceleration is going to be negative. Okay, so let's imagine what's happening here. If the velocity and the acceleration, if the acceleration does happen to be in the same direction, what do we know what's happening here? We know then that the object is speeding up. So we have a situation in which the object is speeding up. So in that case then, the acceleration is in the same direction as the velocity. However, can you have a situation in which the velocity is negative and the acceleration is positive? And the answer is yes. If the acceleration, in this case then, make sure you keep in mind then the acceleration then is also in the same direction. So that's the acceleration there. Okay? In this case, then the acceleration will be in the opposite direction of the velocity. So if the velocity is positive and negative and the acceleration is positive, what's happening here? Well, the object is slowing down. Okay, so the statement here is false because you can't, just because an object is moving in a certain direction with a certain velocity in that direction, the acceleration does not have to be in the same direction. So there are the 2 instances that we have here that we have to consider. The first one where the acceleration is in the same direction, then the object speeding up. Here where the velocity is in the negative direction, the acceleration can be in the positive direction. It can be. It just means then that the object is slowing down. Okay. All right. Very good. Let's go ahead then and let's take a look at the next statement. And I'm sorry, I'm going to flip back to the previous slide. So I get on my notes here. Car slowing down, its acceleration must be positive. Okay, so let's go ahead and take a look at that statement. Okay. So let's go ahead and draw our car here. Okay. If the car is slowing down. Okay, so again, we have an object, okay, that is moving in the negative direction still, okay, moving in the negative direction, okay. So we have that situation, okay. Okay. The acceleration has to be positive. So let's go ahead, and I think that's what the statement tells us. And I'm going to finish this up for you. If the car is slowing down, its acceleration may be positive. Okay. And so let's go ahead and let's take a look at this. So if the car is slowing down, okay, what do we know must be true about the signs of the acceleration and the velocity? Okay? They have to be different. We just did it up here. Okay? And so this statement here is true. This statement here is true because in order for the object to slow down, remember, in order for an object to slow down, in order for us to make that determination, we have to make sure then that the velocities and the accelerations have opposite signs here. Which means then if the car turns around and moves towards the west in the positive direction, if it's slowing down, the acceleration has to be in the opposite direction. Okay, so make sure you keep in mind then that the one thing you want to take a look at here is that you want to look at the signs of the velocity and the acceleration. Okay, and so here we have the vector arrows. If that helps you, go ahead and draw that in as well. But the statement for B then is going to be true. Okay. All right, what I'd like to do then is I've ran out of time here. So I'm going to go ahead and save this, and we will pick up with the last instance here where we have an object that is in constant non-zero, experiencing constant non-zero acceleration. I want to go ahead and talk about that with you tomorrow, and then we'll go over it, okay? All right, so with that said, then please make sure you submit this work here. I know that compare your answers with A and B, and then hold on to your answer for part C, and then we'll go over that tomorrow. All right, very good, folks. I will see you tomorrow.